Hello and welcome to week 11 of our class. We are now well into our final project effort. We have our application idea, we created the design brief and pseudocode, and this week we will be creating our minimum viable product or MVP using VS Code. So basically this week we are turning our plans into actual Python syntax code and testing our application to verify that the main basic functionalities are working as expected. And here are the requirements for this week's assignment. Again, we will be creating an MVP, which means not the very final product of your application, but a working application with no errors. You do not need to have all of your pseudocode working, but you do need to have a functioning program to get full credit. This means if there is a function that isn't quite working, you should comment it out for now. And it's really important to comment your code, as well as create documentation, which is actually part of the assignment anyways. So what you do need to submit this week are two things: the .py code file of your final project and a Word document that answers these questions here. Okay? And of course, if you have any questions throughout the week, please reach out to me either through the Canvas inbox or directly via email, or you can also post something to the Q&A discussion forum. Alright, I wanted to switch gears now and talk about a very common yet very important feature when writing code, and that is debugging your code. So debugging is usually associated with testing and troubleshooting a problem in your code, which is true, but with modern programming editors like VS Code, we can use the debugging feature to check the status of our code and run through it line by line to see what is happening as the application is running. So here I have VS Code opened with a very simple application that just loops through a few numbers and displays factorial values of these numbers. If you still remember from our high school math class, factorial is the product of all numbers from 1 to that particular number. So if I say what is 4 factorial, then it would mean 1 times 2 times 3 times 4, which would be 24. And this code starts off by importing the math module. I use this module because it has built-in methods that calculate many common math functions quickly with very little lines of code. So why reinvent the wheel with numerous lines of code when I can just import a module that has a method for my intended functionality? And in this case, the math module has a method called factorial, which does just that. It calculates the factorial of any number that is passed to it as an argument. So I created a function called calculate factorial that takes one parameter called number, and all that this function does when it's called is to return the factorial value of the passed number using the factorial method of the math module. That's it. Then I have a list of numbers defined that I want to calculate the factorial values for, and I loop through these numbers in this for loop here. So this for loop will iterate through my list of numbers, and with each number it will call the calculate factorial method using that number as the argument. Then print out a statement that states the factorial of this number. Alright, so if I run this program as it is now, it runs with no errors, and the output is the factorial of 3 is 6, the factorial of 5 is 120, the factorial of 7 is 5040, and the factorial of 9 is 362,880. Okay, but what about the debugging features? Well, to run debugger in VS Code, we can do it through multiple ways. For example, on the left panel here, I have some icons, and this play button icon has a bug icon on it, which means we can run this code in debug mode. And when I hover my mouse over it, it says run and debug. Another way to debug your code is to go to the regular run button, but click the pull down arrow next to it, and then choose this Python debugger option. And one more way to debug your code is to go to the Run menu option, then choose Start Debugging. Or you can use the keyboard shortcut of F5. So I'll click this option and see what happens. Now the first time you run debugger, you will get some options. I will choose the Python file option to debug my currently active Python file. Okay, so the code ran just like before. So what's the difference then? Well, nothing yet. You see, to start debugging, we'll need to set up something called a breakpoint. Now, a breakpoint is where the code pauses, allowing you to inspect things like variables and program state. For example, let's set a breakpoint on the line where the calculate factorial function is called. So in my for loop, here is where this function is called. And to insert a breakpoint, I will hover my mouse over in the area just before the line numbers. Now this area is often referred to as the gutter. And you can see that doing so will display a red circle, and when I stop hovering, I see the text, click to add breakpoint. So I'll click, and now I have a breakpoint on this line, indicated by the red circle. This means now that when I run my code, this breakpoint will pause the program's execution at this line. So let's test this out. To start my debugger this time, I'll click on this icon on the left, then run and debug. Now a few things happened here. First, the code was paused at the breakpoint, and the code line is also highlighted. And in the terminal window below, I don't have any output yet because the code was paused before reaching the code that prints out anything. Then in my left panel, I see my run and debug information, which includes things like variables, watch, and call stack, which I'll cover briefly in a few minutes. And do you notice this toolbar in the top center? These buttons let us control the flow of our debugging session. For example, once the code has been paused, we can then continue with our code, step over our code, step into our code, step out of our code. Or we can restart the debugging session, or we can stop the debugger altogether. Now the continue button will let the code continue to run until the next breakpoint or until the code finishes. The step over button will execute the current line, then step over to the next line of code and pause again without running that next line of code. The step into button is when you want to step into a function code block and inspect it line by line. And the step out button does the opposite of step in and takes you out of the function you are inspecting and puts you back on the next line of code outside that function. Okay, so I'm currently paused on this line because it's currently highlighted in yellow. And if I hit continue, the program should continue running till the end since I don't have any other breakpoints in my code. So I'll click continue. The program paused again. Why is that? Well, because the breakpoint is inside the loop, and each time the loop runs, the breakpoint is met and pauses the code. So I'll click continue a couple more times until the loop is done running and the application finishes. Now let me run the debugger code, this time from the top right play button option. And my code pauses at the breakpoint as expected. So the Python interpreter executed all these lines of code and then stopped at this particular line. This means that by now my math module has been imported, my calculate factorial function has been defined, my list of numbers has been created and assigned, plus my for loop has started to run on my first iteration using the number 3 as my first iteration variable. And to verify that, I can simply hover my mouse over the number variable anywhere in my code and it will display the number 3. See? So that's one way to inspect variable values as you go through the flow of your code. You can also see the variable values in the Run and Debug panel on the left. I can also set up a watch item to watch for the value of a particular variable. So I'll click on the plus sign in the watch section. Then in the expression to watch text field, I'll type the name of the variable that I want to watch for. So I'll type number, then hit enter. And now I see the variable with its current value. And if this value ever changes, it will be reflected here as well. Now let's continue with our code and see how things change. So I'm currently paused here, and if I click continue, the application will continue to execute all the code until either it hits another breakpoint or the code is finished executing. So upon hitting continue, this highlighted line of code will run, then this print statement will run, then we loop to the top again for the next iteration. Then we come to this line again, which is a breakpoint, so the program's execution will be paused once again. So let's see all of this in action. I'll click on the Continue button in my Control Flow toolbar, and based on the output here, I see that the print statement of the first iteration in my loop was executed correctly. Then we looped back to the next iteration, and we paused again at the breakpoint. But notice now that the value of my number variable has been updated in both my variables window as well as in my watch list. And if I hover my mouse over the number variable in my code, I also see the current and updated value. So debugging can help us see how things are flowing and changing as our application is running. I use this so many times when I'm trying to troubleshoot a problem so I can get to the bottom of an issue. Alright, let's run this application again in debug mode. And as expected, the code stops at the breakpoint. Now, to control the flow of the application to go line by line, I will click on the Step Over button in the control bar, but only once. What this did is that it executed the code that was previously highlighted, then moved down to the next line of code. So we are now going line by line and seeing how things change in my code. And now, based on the highlighted line, I'm at this line of code, but it didn't execute yet. I'll click now on the Step Over button again, and what this did is that it executed this line of code, which printed out this statement. Then it went on to the next line of code, which is the next iteration of my loop. And notice that my number variable still holds a value of 3. Now why is that? Well, because we haven't processed this line yet. So let's click on the Step Over button again. And now we see the number variable has changed to 5. So we now see that the Step Over debug button allows us to go through our code line by line and seeing everything that happens in the application. Pretty cool, right? Now, while I'm here and on this code, I want to show you the next button in the debugger control flow bar, which is the Step Into button. This feature will allow me to step into a function's code like the function we see on this line. So let's click the Step Into button now. And if you notice what happened here, the debugger took me into the calculate factorial function. And now that I'm in the function, I can also use the Step Over button to go line by line. But I don't want to do that now. Instead, I want to exit the function. So I'll click on the Step Out button. And this takes me back to the same line that called this function. So with Debugger, we have full control on how to move across our code. Alright, let me stop the debugger now so I can show you something else. If I right-click on the breakpoint, I get 3 options to either remove the breakpoint, edit it, or disable it. The difference between remove and disable is that disable keeps the breakpoint but deactivates it so you can use it perhaps once again at a later time. But the remove option, this will delete it altogether. Now I wanted to show you the edit break option, so I'll click on that. And this gives us a few options. The expression option triggers the breakpoint only if a specific condition is true, kind of like an if statement. For example, x larger than 10. Now this is helpful if you only want to pause your program when a variable meets a certain criteria. So let me set the expression to number equals to 5. Then hit enter to save this condition. This now means that this breakpoint will not pause the Python program unless this condition is true. And you can also see that the breakpoint icon now looks a little bit different. And when you hover over it, it gives you the conditional information. And if I run my debugger now, the first iteration ran without pausing because the number was 3. But now that the number is 5, as can be seen in my watch list, so our breakpoint condition has been met and the program is paused. Alright, so let me stop the debugger again. And let me edit this breakpoint once more, but first let me remove this condition by erasing it and hitting enter. And let's edit it again. But this time I'll choose the next option of hit count. This basically says that this breakpoint will pause the code only if I achieve this hit count number. So I'll type 3 and hit enter. And since I'm in a loop, then on the third iteration the program should pause. So let's try that by running the debugger again. And from the output we see that the loop ran twice, and on the third time it paused per our hit count configuration. Alright, let's stop the debugger again, and let's edit the breakpoint one more time. I'll remove the existing hit count, edit, and choose the log message. Here I can type a message that will be outputted in the debug console, not my terminal window. So I'll type "we are a number," and then any variable needs to be surrounded by braces. Then I hit enter. Okay, and let's run this again in debug mode. And as you can see, instead of pausing, this option logs a message to the debug console without stopping the program. And so this is another great way for monitoring variable changes, but without interrupting execution of your program. Pretty cool and powerful stuff, right? Alright, so I hope you can start to debug your code now using the skills in this video. Me personally, I rely heavily on it in my day-to-day coding effort, and I hope you do the same. Okay, thanks for your time and thanks for watching this video. Please let me know if you have any questions, and I'll be seeing you in class. Take care and bye for now.